this lecture, we will talk about drawing, splitting, and shape manipulation of NumPy arrays. So shape manipulation, during the creation of a two-dimensional arrays, it is possible to convert a one-dimensional array into a matrix using the reshape function. The reshape function returns a new array and can therefore create new objects. So for example, A is a one-dimensional array with 12 elements, random number between 0 and 1. Then we can write capitalized A represent a matrix and use A dot reshape with a tuple 3, 4. Then A will be created as a two-dimensional array with the shape 3, 4. And elements comes from this array. And you can also use a tuple to modify the shape of an existing array, so we can assign a new shape to this array's shape. So now A will be a two-dimensional array with the shape 3 by 4. And to inverse, the inverse operation is also possible, such as you can convert a two-dimensional array into a one-dimensional array by using the revel function. So we can write A now. A is a two-dimensional array. Then we can write A dot revel parentheses. The A will be returned to a one-dimensional array with 12 elements, or even acting directly on the shape attributes of the array itself. This the same method as in previous page. So A dot shape, we can write a one-dimensional array in a tuple. Then A will be returned to a one-dimensional array. And if you want to transpose a matrix which is inverted columns with the rows, you can use NumPy's transpose function. So A matrix, a two-dimensional array with the shape 3, 4. We write A dot transpose parentheses, and A's shape will be 4 by 3 now, 4 rows, 3 columns. And the drawing arrays, you can merge multiple arrays to form a new one that contains all of the arrays. NumPy uses the concept of stacking, providing a number of functions in this regard. For example, you can perform vertical stacking with the vstack function, which combines the second array as new rows of the first array. By contrast, the hstack function performs a horizontal stacking, that is, the second array is added to the columns of the first array. So A and B both are matrix with 3 by 3 shape, two-dimensional. Then we can use np.vstack AB. Just be careful that here is a double parenthesis here. Then this will return a new matrix, two-dimensional array with the shape 3 rows, 6 rows, 3 columns, and np hstack will stack these two matrices horizontally. So the result will be a new matrix, two-dimensional array with the shape 3 rows and 6 columns. And the two other functions performing stacking between multiple arrays are column stack and a row stack. These functions operate differently than the two previous functions. Generally, these functions are used with one-dimensional arrays, which are stacked as columns or rows in order to form a new two-dimensional array. So A, B, C are all one-dimensional array with 3 elements, same shape. Then we can write np.column underscore stack with the double parenthesis ABC. Then the column of these 3 one-dimensional arrays will be combined into one two-dimensional array. And if we write np.row stack ABC, then the rows of each one-dimensional array will be combined into a two-dimensional array. And splitting arrays. To divide an array horizontally or vertically into several parts, you can use NumPy's splitting functions, hsplit and vsplit. For example, if you want to split the array horizontally, meaning the width of the array is divided into two parts, the 4x4 matrix A will be split into two 4x2 matrix. So A is a 4x4 matrix, two-dimensional array. Then we can write bracket B, C equals np.hsplit A, 2. So A will be split into two-dimensional array with each with a shape of 4x2. So both B and C are two matrices with a shape 4x2 now. And instead, if you want to split the array vertically, meaning the height of the array is divided into two parts, then the 4x4 matrix A will be split into two 2x4 matrix. So here, if we write np.vsplit A, 2, then both B and C will be a two-dimensional array with the shape 2x4. And a more complex command is the split function, which allows you to split the array into non-symmetrical parts. So passing the array as an argument, you have also to specify the index of the parts to be divided. If you use the option axis equals 1, then the index will be columns. If instead the option is axis is 0, then they will be row index. For example, if you want to divide the matrix into three parts, the first of which will include the first column, the second will include the second and the third column, and the third will include the last column, then you can write A1, A2, A3 in the bracket in the left side. Then the right side is np.split A, then a bracket, a list 1, 3, then axis is 1 by column. Here 1, 3 means the matrix will be split in the position of these columns. So 1 represents the second column, and third means the fourth column. So in the end, the matrix A will be split into three parts. The first part is the first column, and the second part is between these two is the second and third column, and the third part is the fourth column for these three matrices. And similarly, you can do the same thing by rows. So here we just change the axis to 0. Then A1, A2, A3 will be three matrices with the first row, and A2 is the second and third row, and A3 is the fourth row of this matrix A. We will show these statements in Anaconda Spider now. I can open the file section 10, the NumPy library.py, and the link to this file will be put into the description of this video when all the lectures in this section, in section 10, will be finished. So we move to the lecture 5, drawing, splitting, and shape manipulation of NumPy array. So first see shape manipulation. We import NumPy as np, then create one-dimensional array, a 12 elements, 12 random number between 0 and 1. You can write and create a new array called a new matrix with a reshape with a tuple 3x4. Then A is a 3x4 matrix, and we can use the same alternative way. Write A dot shape is 3x4. Then A will be 3x4 matrix now, and we can convert a two-dimensional array into a one-dimensional array with the level. So A is now two-dimensional array. So we can use a dot level parentheses, then change it back to a one-dimensional array. So now A is one-dimensional now. And we create a matrix for A again. So we create a matrix for A. A is two-dimensional again now. Then we can also use an alternative way, right? A dot shape is 12, because here is a one-dimensional 12 in the parentheses. Then we'll see A is also one-dimensional now. And the transpose, we can write A dot transpose. Then A will be 4 row by 3 column matrix now. And drawing arrays vstack and hstack. So A and B are both two-dimensional array. So we can see NP vstack AB double parentheses AB, the 6 row 3 column matrix, and NP hstack AB will be 3 row 6 column of a two-dimensional array. And the column stack and the row stack, so A, B, C were all one-dimensional arrays created. Then we can use column underscore stack A, B, C. So the column of these 3 arrays will be combined into the first row of the resulting matrix. Columns here will be the second row. Columns will be the third row. So if we use row underscore stack ABC, then it will be very clear. The row is the row, the same. And splitting arrays, A is a two-dimensional array with 16 elements, 4 by 4. Then we can write bracket B, C in the left side. The right side is NP H split A2. We'll split horizontally. Then we show B. And B is a 4 by 2 matrix, and C also 4 by 2. So split horizontally from A. And if we split vertically for matrix A, then B will be first 2 rows of the matrix A, and C will be the next 2 rows of matrix A. And if we use a split, we can add the columns and the row or rows we want to split from. And this axis 1 is by column. So show this. So now A1 is the first column of the original array. A2 is the second and third column, and A3 is the last column of matrix A. Similarly, we can use axis 0 to split horizontally. Then A1 will be the first row of A. A2 will be second and third rows of A. A3 will be the last row of A.